Layer H.E.R, one of the protocol on Starknet just released the mainnet yesterday, and in fact, a quest is coming. It started, sorry, on Starknet Quest, so it's a way for you to learn more about it and to test it. So, for example, you can start by clicking on begin, answer the first question related to it's like a three question on this quiz, follow layer electronics, and test the application by swapping $10. So it's a great way for you to test application and as well to get reward if you are selected. So don't hesitate to explore Starknet Quest, like I said yesterday. and yeah. So let's start. Let's start. So just application. Okay. So today we're gonna talk about architecture. It's one of the biggest workshop, but I read this one to be more friendly and avoid any confusion and stuff like that. So yeah, basically we're gonna cover architecture. So we are at the basic days, like we said just before. And the session topics are more especially related to the architecture 101, the transaction, finality, full nodes, and recursive proving. So that is something interesting on Starknet. And we're gonna finish with a test and two quiz during the session. So the two quiz will be displayed during the session to avoid any overload of work just after that. Yeah. So let's start with the architecture. So just to architecture 101, it's oversimplified, but basically what you can do, in fact, you have on your laptop a H.E.R program, and in fact you're gonna compile it to H.E.R, a H.E.R file, and why we are using right now H.E.R, it was not the case before. It's just because a few transactions that will fail was not like included inside the block. So it's important right now for the like to have this one included just because the sequencer has to be compensated for that. So right now we have the H.E.R representative, like intermediate representative things between inside the architecture. And basically after that, so the serial file is sent to the sequencer, and the sequencer is compiling this serial file in H.E.R assembly script. So it's one of the representation with it. And the H.E.R assembly script code is run into the H.E.R VM. And then we're gonna generate trace that we're gonna send to the prover. So the prover is called H.E.R on Starknet, so it's like shared prover. And in fact, this one is shared with other protocol to be more performance. And that's why it's called shared prover. And at the end, so the prover will generate a validity proof, and this validity proof will go to the Ethereum just to like some node operator will verify if the validity proof is correct or not, and if it's the case. So as a result, we have like a layer 1 finality where the proof is on Ethereum, in fact. So it's oversimplified, like I said. And all smart contracts on Starknet have to be declared in the brain. So why we have to declare a smart contract? So basically, in fact, declaring on Starknet is one of the features that not really exist on other blockchain like Ethereum. So in fact, we are declaring a smart contract to to have this one available, the code available directly on Starknet network. And yeah, declaring a smart contract is like known as a contract class or slash blueprint. We said that. And when you declare a smart contract, you just really put the code into Starknet, so you don't have any storage, and to have a, oh yes, to be able to define this one, you need to create a contract instance. So for that, you need to use the contract class. So you have to derive this one to just have some address and unique storage associated to this one. So yeah, it's important that you have to keep in mind that you have to declare and deploy your smart contract on Starknet, and yeah, yeah, yes. So for deploying, in fact, Starknet is using something. It's using a universal deployer. So this one is a special smart contract that deploy other smart contracts, and it's directly incorporated for abstraction, and like we are using this universal deployer writing in Cairo 0, so we have to upgrade that, but it's in ongoing stuff, and Open Zeppelin is behind this project, so this contract, so everyone can use it on Starknet as a public good. It's important to mention that. Actually, it's open source word. So just a summary about this first section, really succinct. So first, you have to compile your Cairo program to H.E.R. H.E.R will compile your H.E.R file will compile to safe chasm, so Cairo assembly script, and you have to declare to create contract class. So just you don't have a storage at this time; it's really pure code. And you can create contract instance to have your unique address as liberated from the contract class. And yeah, for deploying a smart contract, you have to use a universal deployer. Yes, I think Charlotte, do you want to add something? That's fine. Okay. Yes, because you yes. Yeah, you can take a picture. Um, in fact, at the beginning, a few process like that are in the presentation, but it's probably too much. So that's why we simplified by this way. Is it okay for you? Okay, all good. We can continue. Yes. So right now you're gonna switch to the transaction parts. So the first one was most complicated if you starting. So regarding the transaction life cycle, which look like, so with your smartphone you can initiate transaction and sign this one, in fact, and then this one will go to a mempool. So mempool is just like a way to whole transaction as going pass by this thing, just to be carry on. I don't know the term. And the sequencer will check if the transaction have a correct structure. And based on these results, so you're gonna have receive or in your. So usually it's just a receive a statute, and in your the sequencer put in your it's just only receive or that's gonna just disappear. So the next thing is to see if the signature is valid. So for that, you just have to check like if it's really made by you or not. And if it's not the case, this one will be rejected by security. And we can continue the process if the state is not in change. Like in fact, we have a different statute. So receive or in your when the correct the structure of the transaction is correct. We have the signature valid, so it's unchanged, so you can continue the process. And if the Cairo VM, like the transaction passing the Cairo VM and it's okay, it will be accepted on layer 2. And this one can be reverted if you don't have any Enos gas or something like that inside your wallet. And yeah, otherwise, after that, yeah, the process is to the trace of this transaction will be sent to the prover, so SHA, as usual, the shared prover, and this prover will create a validity proof. So basically, the validity proof will be verified on Ethereum by node operators like before I told you. And if the states of this proof is okay, so we're gonna have accepted on layer on L1, sorry. And it's layer 1 finality. So we have different type of finality. The first one is related to here, the accepted on layer on L2, and the layer 1 finality is accepted on layer 1. Yeah, it's like the state. So right now, we're gonna take a look at the transaction type. So in fact, we have 3 transaction type. So the first one, I already talked about it, is the register, the new code on the Starknet network. So it just a code, like I said, a pure code without any storage. While when you are using the invoke transaction type, in fact, the universal deployer is behind this one, just to deploy your smart contracts, and you can after that write that you are going to you are able to write functions to modify the states, the global states of your smart contract. And for that, in fact, you have to pay gas because when you have to write, you have to modify something. So when you have to modify, you have to pay. Contrary to the function read only, so like you can see this one here, because when for example you just want to take a look at who is the owner, it's just read only, so you didn't modify anything inside the smart contract. So the global state stays the same. And another one transaction type is the deploy icons. So it's more related to smart wallets. So Charlotte talk about it just before, and we will take a look at it just right now. Do you have any question on chat? Check. Okay. So in fact, just we have something on on the Starknet. When you want to create smart wallets, you have to deploy an icon contract, and but that's the process is is right now super simple, thanks to the counterfactual deployment, but I will explain why. So, in fact, how do you deploy your icon contracts? So, it's quite different compared to regular smart contracts. If you want to create a smart wallet, so you need to deploy an account, you need to pay gas for that. And then you're gonna have your smart wallet. So it's not stupid, but if you have to deploy your smart wallet, you need a smart wallet for that. It's not like ideal. So you should be able to deploy an account contract without having a smart wallet. So for that, that's why we are using counterfactual deployments, and just yeah, or you can do that. So everything is really abstracted by the wallets Argent and Bravo, so you don't need as a user to take care about it. So it's directly done when you are creating a wallet, and yeah, you can like yes, leverage in fact this property to make a contract pay for its own deployment just by sending funds in advance. So you can pre-fund your wallet by this one. And like I said before, you don't need to take care about it as a user. And for explaining a bit the steps behind this thing when you are a user, but you don't need to take care of that. In fact, that's gonna just calculate the address on chain, send funds to this will be addresses because they can like guess what will be your future address, and then deploy an account using the deploy account transaction. And at the end, yes, the sequencer deduct gas fees from this address. And yeah, it's something important on Starknet. Okay, just a summary about transaction states. So we have three transaction type: declare, invoke, and deploy icons. So for deploying icons, it's more related to counterfactual deployments, and for the life cycle, sorry, we have four major states. So receive, accepted on layer 2. So layer 2 finality, like I said before. Accepted on layer 1 with a layer 1 finality. So it's when the proof is accepted, and rejected or reverted. Yeah, and that's all for this part. Like I said before, I try to simplify a maximum for you. Right now, we're gonna talk about transaction finality. So on Starknet, the transaction finality is really fast. Charlotte already talked about it. So just for recap, you can see that on Ethereum, the finality for the transaction is 6 minutes. On Starknet, is 10 hours, but behind that, you don't have to pay a lot of fees. And right now, the finality, just the layer 2 finality, not the layer 1, because like in fact, it's the layer 1 finality. So after doing the accepted on layer 2, they have to be accepted on layer 1. So this thing has been accelerated for the layer 2 finality, but not the layer 1 finality yet. And optimistic rollup take a lot of time, like 1 week, around 1 week. So layer 2 versus layer 1 finality. So what's the difference? So layer 2 finality, like I said, is related to be accepted on the layer 2 first, before being accepted on the layer 1, where the node operators will operate to push the validity proof on the network. So on Starknet, they takes 2 seconds. Before 1 month ago, it takes like 10 seconds. So thanks to the last updates, so the Starknet board updates, right now it's 2 seconds. It's trusted by Starkware. So Starkware it was in charge of these developments. And it's used by most applications on Starknet right now. And more related to just let me check one thing. Yeah. So the layer one finality is completely lossless. It's important to know that. It takes around 10 hours to be pushed into the Ethereum network. And it's more used by bridge to extract data by this way. And what is the exact event timeline? So first, the sequencer receives transaction and batches this one. Verify, like just push this one and verify it with the Chirobium. So the transaction is executed or not. Then every 30 seconds, a block is created. And at the end of the process, so the validity proof is verified on the layer one. So it's the layer one finality. So you have two things like layer one finality and layer two finality, like I said. It's important to have this term on your mind. So just summary, the transactions are executed in this order of they arrive so through the mempool in the sequencer. So the sequencer just batches this one and orders this one. The new transactions that arrive into a block are in pending block until the sequencer take care of this one. And transactions are executed after reaching the Cairo VM. And then we're gonna have the layer two finality at this time, and the transaction take 2 seconds to do all the process after. Well, in fact, when you send the transaction on the network, they take really 2 seconds to be confirmed accept on layer two or not. So, for example, just for more context, I think it's better if I do a demonstration, like let's say on H.E.R swap or Avenue, just to show you the layout finality. So trade on Starknet, launch app. I think it's better with an overview, an example. Let's book this amount. Connect the wallets, Argentix. Okay, I'm connected right now. So I'm gonna swap. And in fact, the time that I will swap, I don't have to take a look at the pending status of the transaction. Yeah. So view. Oh, that's here. No, no, no. In fact, oh, I want to see the transaction on. Wow, I can see this one on directly on Starscan or Voyager. Function. Transaction function, yeah, but okay. So I will go to H.E.R swap. Oui, c'est vrai. Mais c'est pour montrer sur Voyageur et tout qu'il y avait vraiment qu'à accepter dans le meilleur. Ah oui, 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 sure. Yes, yes. That's it. So I will go to wallet story. So yes, you can see here. The next one is, sorry. I've almost finished the presentation. It's a bit slow. Otherwise, I will go to Angola. And yeah, okay, deposits, confirm. You can see the low fees. And right now, oh yes, but still doesn't. Oh, yeah, that's a view on Explorer. And you can see that everything is already accepted on layer 2. Like, yeah, it's a step, in fact. Soon, I'm pending, accepted on layer 2. It's super, super fast. And the next step will be accepted on layer 1. And we have to wait that node operator operates on the Ethereum network. Yeah. Okay. Let's go back to slide. Yes. So right now, full node. I don't know if it's no. I'm still a bit of content there. Okay. So the role of the full node is to just you can query all of the data that's on the Starknet blockchain. So you can like the full node will answer all question about the Starknet network states. And the user don't directly interact with the questions. The question sequencer is really just the role of the full node, and it's similar to an execution client on Ethereum that you can use the H.E.R persistent server to get information about different transactions. And on Starknet, we have different full nodes. Keep in mind this one. Juno, Passenger, Pybulus, and Madara. So yeah, it's operated as full node for Starknet. Yes, I already talked about that. Proving. So basically, on Starknet, like I said before, we have a shared prover, and this prover we have multiple protocol on top of that, on top of it, that allows to run some module and have like a the shared prover. And inside this prover, we have a lot of modules in parallel that run improving independently a lot of validity proof. So just to remember, it's really like we have a couple of protocols that allows you to create the shared prover at some like I don't know how to do that, how to say that. It's like 1 + 1 = 2. So, je sais pas comment l'expliquer en langue. In fact, you are using the same basis and replicate it to create some recursive proof. Like the same schema every time, just it's super large. I don't know how to say that, but anyway, in fact, the result of this recursive proving is to have a great verification cost that is super low. Like you said, you can see that no recursion. You have a lot of the cost is more, and when we are using one level or higher, the term was level, one level of recursion. So it's less, But if you are adding another level, it's again low, and so on. So you can have, I don't remember how many level, but too much level, no, so many level. And that's why the cost, verification cost is super, super low on Starknet. Sorry for... Yeah. And the other advantage and the time of the layer one finality. So this one is reduced when we have some level of regression as well. So like I said, more you are level, more is cheaper and more the time is fast. So just to summarize, so H.E.R is using multi-protocol, like I said before. And with the recursion proving, so in fact, you can reduce layer two transaction cost and reduce the time of the layer one finality. So the layer one finality is the validity proof that is generated on Ethereum, like it's validated on a Ethereum network. Yeah. So it was the end. Right now, it's really the last session test that you're gonna have this week. So I will put this one, and